Good morning, students. This is the practice quiz flag video. I'm going to be explaining the problems here with flags. Taking a look here, number one, it says that we want to state if the polygons are similar. And remember, similar, you want to remember the acronym SCARE, S-C-A-R-E, which means similar shapes have congruent angles and ratios which are equal. So taking a look here on the left, first thing you're going to notice, of course, is the parallel line. I'm going to trace and stretch those out. And if you have parallel lines, we have stir sticks here, and these angles, if they're parallel, add up to 180 because they're same side interior. So if that's 70, that must be 110. If that's 110, that must be 70, which means our first category for congruent angles is true. So we have congruent angles because of the parallel lines. Now let's take the side ratios. So I'm going to go 8 to 24. 8 goes into 24 3 times. That's a 1 to 3 ratio. And 5 to 15, that's a 1 to 3 ratio. Then I have 8 to 24, 1 to 3 ratio. 5 to 15, 1 to 3 ratio. And so we see the ratios are also equal. This is yes, the shapes are similar. Taking a look at number 5, it says solve for the polygons that are similar. So we know they're similar. So the minute is something is similar, we know we can do a proportion. Let's take a look at what we do know. We know we have a scale factor of A to B of 1 to 3. It's important that you get the correct direction. We're going from A, circle the 1, come up here, that's 1, to B, box the B, box 3, come up here, box the B, that's 3. And we're going to go this direction, A to B. So I'm going 1, 2, 3, and then you match the other two sides up, go in the same direction. Please draw the arrows. You match it up, cross multiply, and solve. Says we're going to state in each pair if they are, state if, it's a key word, if the triangles are similar. Then if they are similar, state how you know they're similar. So that word know means we're looking for side similarity, angle similarity, or side angle similarity. So first we have to state if they're similar. So you might have to check for one of these three. If they don't fit, then they're not similar. Whenever I have overlapping triangles, your very first instinct should be to trace and pull them apart. So start tracing, pulling these apart, and pull your numbers over. That's 55. That's 45. 72 minus 112. That's going to be 40. And then you have the larger overlapping triangles. Make sure you're looking at the correct numbers here. This is 154. This is 112. And this whole side is 126. So obviously we need to check for ratios here. So we're going to reduce 40 to 112. I'm going to try 4 first. 4 goes into 40 10 times, and 4 goes in here 1, 2, 20. That's going to be 8 with 3 left over. That's 32. And 4 goes into 32 8 times. So we can go farther because 2 can obviously go into both of these. So 2 goes into 10 5 times. And 2 goes into 28 7 times. Now I'm going to check the other sides. So I have 55 and 154. So I'm going to check the 5 to 7 ratio. And 11 goes into 55 5 times. And 11 goes into 54. Okay, we reduce this by 2, so this is 14. So it's 5 to 14. Let's check here. 11 goes in here once with 4 left over, 44, so that's 14. And let's check 5. 5 goes in, 9 goes in here 5 times. And let's check 126 and 9. 9 goes in there once. And that's also 14. So notice we have 5 to 14, 5 to 14, 5 to 14. So yes, these are similar by, yes, by side, side, side similarity. And if they are, you need to align the vertices. So STU, that's STU is therefore similar to SDE. Taking a look at here, we want to find the missing length. Trace and pull these triangles apart. That's 8 and 14. This is our unknown. This is 21. And we're going to make a proportion. Now, it doesn't matter which direction we go, whether we go top, bottom, or where we go bottom, top. What does matter is that we must be consistent. So I'm going to go top, bottom. So I'm going to go 8 over x equals 14 over 21. And we cross multiply. So we're going to have here 8 times 21. Oh, time sign does not look like a time sign. Let's try that again. 8 times 21 equals 14x. Remember, the key to multiplying is not actually multiplying. It's factoring. So we're going to take here, and I'm going to factor. I'm going to circle 14 and 21. 7 goes into both, so 7 goes in here twice. 7 goes in here 3 times. Let's box the 2 and box the 8, and 2 goes in there 4 times. 4 times 3, we get x equals 12. Here we want to solve for x. So once again, I like to pull these triangles apart. Make sure you bring your numbers over very carefully. and make a proportion. From here, it's just a matter of matching and mirroring. Match and mirror. So you make your proportion from here and cross multiply and solve. I could do that way, top, bottom, top, bottom. I can go this way. So I'm just showing you the different ways. Bottom, top, bottom, top. I could even go within, you know, right, down, right, down. See all the different ways you can do this? It's all about match and mirror. Choose the direction that feels most instinctual to you and then mirror it. So for parallel lines, it's all about matching and mirroring. So we can match 15 and 12. And then we're going to match 4x minus 7. And the problem is, careful there, trace it. That's not 32, my friends. Be very careful that you don't use your eyeballs here and just pick up that large number because you see it. Physically trace. We need that segment there, and we actually don't have it. Squiggle. So we see 32 minus 12. And we see that's 20. Now you can make your proportion. And you can go right, left, right, left. You can go left, right, left, right. You could even go top, bottom, and you can even go bottom, top, bottom, top. Once again, you just must match the sides and mirror the motion. Mirror the motion. All four of those are correct as long as you mirror properly. Notice all the arrows go the same direction. Left, right, top, bottom, etc. This was in the preview notes. So let me just paint the scenario because you only saw this once in the preview notes. Draw a triangle here, sweep this corner. If there's an angle bisector, and your eyeball is looking here, an angle bisector, this is true. This side over this segment equals this side over this segment. Side over seg equals side over seg. Notice the pattern here. Side over seg equals side over seg. So let me get you started on 24. So we're going to go side, I'm just going to write it out, side over segment equals side over segment. So our side is 45, and our segment here is 27, and our side over here is 20, and our segment, careful here, we're going to call it x, but that's not ultimately what we're trying to find. We cross multiply, we're going to solve for x, and you should be able to see that x is going to equal 20 times 27 divided by 45. The key to multiplying is not multiplying. It's factoring. So I'm going to go circle 45 and 27. 9 goes in here 5 times. 9 goes in here 3 times. I box the 5 and box the 20. 5 goes in here 4 times, so I see here that x equals 4 times 3, which is 12. And that's not ultimately what I want. What I ultimately want is this. So you do that final step. This one here, let's go over again what we talked about. It's going to be side over seg, segment, equals side over segment. Side over seg equals side over seg. Now, that obviously doesn't get us x yet, but let's see what we can find here. Our side is 15. Our segment, I'm just going to use an empty box. You don't mix it up with x there. And then this side, of course, is 10, and this segment we have is 6. Our box is going to equal 15 times 6 divided by 10. Cross these out. 5 goes in here twice. 5 goes in here 3 times. Going this way, box the 2 and the 6. 2 goes in here 3 times. So 3 times 3, x is 9, or box is 9. Now we take a look at what we want. We want to solve for this segment, and we see that this segment actually equals 9 plus 6, so we can do this. 2x plus 7 equals 9 plus 6. And you can take it from there.